Hello, welcome back, ladies and gentlemen, to Math 1B. This is super weird because I'm talking to an empty classroom right now, but you get the gist. This is the best I have to offer now that we're sheltering in place, social distancing, washing our hands, making sure we're not putting ourselves in risk with a lot of people together. So hopefully you guys are you're staying safe and healthy, looking out for each other. Please make sure you guys are going to Google Classroom. What I'm doing is I'm going back and talking about things that we've already studied. So we're starting with an August 2019 concept that I brought before you guys with exponent properties. I thought this would be a good opportunity just to kind of see what you know. From then, maybe taking that and extending it a little bit so that our understanding is a lot stronger. I only have 6 problems for you guys tonight to do as like quote homework. And if you look on Google Classroom, you'll see everything we have to do there. The notes are also attached to Google Classroom, which is what I'm going over. I've got about 15 minutes. I'm going to try to get through 6 examples. If I don't get it by the end of 15 minutes, I will scan them onto Google Classroom for you guys. Okay, we got 2 goals. Be able to compute products of powers and be able to simplify entire powers applied to an exponent. So our first goal is kind of illustrated right here in this first example. How do we compute products, which just means multiplication of powers, which are basically variables or numbers taken to an exponent. So these parentheses separating different groups indicate multiplication. And inside of each of these groups, when you put 7 side by side with an x, it's implied that there's multiplication there too. So really what we have is just a giant string of multiplication. By the way, if you ever see a negative out front, just make it a number 1 to avoid confusion, because it really means negative 1xz, not like x to the negative 1 power. All right. So now that we've got straight up multiplication, you can use what's called the commutative property to say, look, I don't know what 7 times x is, but I do know that 7 times 5 is 35. And since these parentheses are just basically acting as multiplication and they don't have any exponents applied to them, you can just remove them. And then you can say to yourself, the 5 and the z squared can flip. The 5 and the y squared can flip. The 5 and the x can flip. So you can say the 7, the 5, and even this negative 1 over here, using the commutative property, can just be multiplied together. So this, and this has been reorganized, still multiplication, in that order. We can also do that with the x's. We can do that with the y's. And we can do that with the z's. Z squared and z. All right, so the first one isn't too much of a brain buster, right? 7 times 5 is 35, times negative 1, negative 35. The coefficients should be pretty basic as far as how you multiply them. Now the x's can be a little trickier, but I would just suggest that you guys think about it like this. Here's x times x cubed times x. X cubed is simply x times itself 3 times. And then we have times x times x. There's 1, 2, 3, 4, 5 x's multiplied by one another. So this is x to the 5th. This is x to the 1, x to the 1. 1 plus 3 plus 1 gives you 5. So all we got to do is add the exponents, and that saves us quite a bit of time. So if we go back here, this will be x to the 5th power. This will be y to the 2 plus 2 power. And this will be z to the 2 plus 2 plus, there's always an implied 1 there, 1 power. So it's z to the 5th. And you don't want to like try to glob it all together at the end by adding the 5 and 4 and 5 over here. The x's can only interact with x's. the y's can only interact with y's, and the z's can only interact with z's. Putting them side by side in multiplication is fine, but you're not going to take an exponent from an x and kind of try to combine it with an exponent for a y. Okay. Goal number 2. Be able to simplify entire powers applied to an exponent. So here's an exponent, and here's an entire term with powers b to the 5th a with that -4 in there. Now again, as I expanded x cubed down here to x times x times x, I technically could say that this is just -4 ab to the 5th times itself 3 times. 1, 2, 3. And technically now it looks exactly like our first example with 3 different, they're called monomials. We talked about that a while ago. I won't use that terminology too much, but it just means we can group all the 4's together, group all the -4's together. We can group all the a's together, group all the b's together. Now, -4 times -4 is 16. Take that times -4, you'll get -64. By the way, feel free to use a calculator to ease the burden of that calculation. And then a, add them together, you get a cubed. 5 plus 5 plus 5 is 15. And you've got your answer there. Now, that's a basic way of literally just applying goal number 1. So you can simplify entire powers by making it look like an example where all you got to do is goal number 1. But the shortcut here, I don't know if you spotted it, but I'm basically taking 3, the exponent out here, times the exponent in here. What's 3 times 5? 15. There's a 1 for the a. There's like that implied 1 always. 3 times 1 is 3. Yeah. But then you've got sort of a 1 here. Sometimes people get messed up with the coefficients. So a lot of times people will be like, hey, let's take 3 times 4. Well, 3 times 4 is not -64. You have to multiply it by the exponent. So it's technically like you have -4 to not the first power now, but -4 to the 3rd power, which is what -4 times -4 times -4 is. So that's the shortcut. The shortcut is you multiply the exponents inside the parentheses by the exponent that's on the outside of parentheses to simplify this thing. Okay? So let's see how that works in an example that has maybe a little bit more going on. So check out number 3 here. On number 3, it seems like we have to deal with these exponents that are on the outside. Let me write this bigger so you guys can see it better. Okay. These little exponents on the outside can easily be applied to the ones on the inside by just saying there's a 1 here, so that's y to the 3rd power. There's a 1 here, that's x to the 3rd power. And then it's -1 to the 3rd power. So that's literally -1 times -1 times -1. And that might be a good idea for you guys just to write it out as such, as -1 times -1 times -1. So this ends up being 1 times -1. It's -1 x cubed y cubed. All right? So the reason why I had to deal with the exponent first is simply because the order of operations, remember that PEMDAS from way back that just keeps showing up over and over and over again? Exponents is the E in that. Exponents have to come before multiplication. So I had to apply this 3 to everybody inside the parentheses before I could start rearranging x's to be with x's and y's to be with y's. So do the same thing here. The z is now going to be squared. The y is going to be to the 7 times 2, which is 14. And then the x is going to be to the 18 times 2, which is 36. All right. And there's like an implied 1 out front here. I don't know if you need me to see that. Maybe that's not a bad idea to just put it there. Just to say, everybody's got a coefficient. So yeah. If you rearrange things now, the coefficients go together. The x's go together. The y's go together. And the z's, there was only one of them. There was, well, z squared. And basically all you do is apply that shortcut on the first step, and then you go back to what you basically go back to what you did on the very first example on the second step. Yeah. And I know some of you guys are probably just saying, I can see it. I don't even have to rearrange it. 3 and 14 is 17. 3 and 36 is 39. -1 times 1 is -1. And then you have a z squared on the tail end of that. I'm okay with you just working that out that way. I just think grouping it together like this is good structure, good organization. And once you become a master of it, that's when you can sort of back off, I think. All right, pause the video. Try number 4 on your own. All right, unpaused. You guys tried this to the best of your ability. Let's see what we got here. So for the first group, I'm going to do in a different color so we can see this a little bit better. We will go red. So for this group right here, 4 to the 3rd power is -4 times -4 times -4. This 3 gets multiplied by the 2 and the 3 here. It's m to the 6, n to the 3rd power. All right, we're going to make this puppy green. So then you're going to have -5 times -5. And then it's going to be n to the 4th power, because you're multiplying those exponents, and then n squared. Now, I can just take these coefficients, -4 times -4 times -4 times -5 times -5. I can crush them all together and multiply that all at once. So this is going to be -64 times +25. All right, you got to keep track of those negatives. So there's my first group. M's are going to be m to the 6, m to the 4. So we're adding the 4 and the 6 together to get m, this will show up better, m to the 10. And then we're going to take n to the 9 and n to the 2. Group those together, that's going to be n to the 11. 64 times 25, that's a calculation you guys can probably do. I think that's -1600 though. And you've got your final answer here. I'm going to leave the last 2 examples as examples worked out for you guys to see on Google Classroom. Hopefully this was helpful in just getting you guys jump-started. Do the first 6 problems on day 127, the document that is attached in Google Classroom. So, good luck. Please email me any questions you may have. And yeah, that's all I got.